Hello everybody. Today we're going to continue our lesson on factoring. So let's just start with a little bit of a review discussing what we did last time we were looking at factoring. So one thing we did was look at common factoring, and that would be the idea that we are going to remove or we're going to factor out a value or a variable or both that is common to all the terms involved in our expression. That was day one. Day two we looked at identifying those two magic numbers or the factors that would multiply to our C value and add to our B value in order to use decomposition as a factoring style and factor the quadratic. Today we're going to continue in that with a little bit more complicated problems. So as I was just saying, we looked at factoring quadratics where the A value was equal to 1, and that was last time. Okay, now we're going to look at factoring quadratics that have an A value greater than 1. So if you look at the equation here, 4x squared minus 8x minus 5. The A value here is 4. Every quadratic that we look at today is going to have an A value greater than 1, and it's going to follow the same steps. There's just a little bit more work that we have to add to what we did last time. In order to factor quadratics in the form ax squared plus bx plus c, when you have an A value greater than 1, you must do the following. So before we were looking for two magic numbers that would multiply to our C value and add to our B value. Same concept today, except for we're not looking for values that multiply to just C. We're looking for factors that multiply to the product of A times C. So whatever A times C is, that's what we're looking for two factors or magic numbers that multiply to. So use the same steps as before, two numbers that add to your middle term, we're still looking for that, and multiply to the product of A times C. So when you're completing your side t-chart here, what you're going to have is two numbers that add to your B term here, okay, and then on your right, still multiplying, but what is A times C? Well, let's go back to this example here. A is 4, C is negative 5, therefore it would be negative 20. You're looking here in this instance, two values that would multiply to negative 20, but also add to negative 8. We'll do a number of examples. Feel free to fast forward a little bit if you want to move on in the video if you feel uncomfortable. Be aware that the problems do get a little bit more complicated as we go through. Just because we did something in problem A doesn't mean that it's going to apply to problem E. Alrighty. Factor each of the following. So first things first, we need to make an adjustment to what we have here. In our equation B, it should be 12x squared minus 25x plus 12. So change that on your sheet. But we're still going to start with problem A. Okay, so what we have here is a quadratic. Our A value is 4, B value is negative 8, and our C value is negative 5. We're still looking for two terms that add to our B value, which is negative 8, and they multiply to whatever A times C is. Well, A is 4, C is negative 5, 4 times negative 5 is negative 20. So, what are the factors of 20? You have 1 and 20. You have 2 and 10. You have 4 and 5. And what combination of either using these as positive or negative numbers can you use them to add to negative 8? Know that one of these numbers has to be negative and one has to be positive because we have a negative C value. If that's true, the only combination that would work here is if we had negative 10 and positive 2. Negative 10 times 2 is negative 20, and negative 8 is equivalent to negative 10 plus 2. Okay. So what do we do here? We rewrite our A term, and we split our middle term into those two magic numbers. So negative 10x plus 2x minus 5. Remembering our steps from last time, we need to pair these, our first two terms and our second two terms, in order to factor them. And then what we do here is we common factor. Same thing as last time. Well, what is common amongst 4x squared and negative 10x? The greatest constant that you can factor out is 2, and you can also factor out x. If you factor out 2x from 4x squared, what are you left with? 2x. If you factor out 2x from negative 10x, you're left with just negative 5. Okay, what is common amongst our second pairing, 2x and negative 5? Well, there is no value that is, or constant that is common. So, the only one that's common is 1. What does that leave you with? 2x minus 5. Remembering if we have the same thing in our brackets here, we are correct. Keep moving forward. 2x plus 1 and 2x minus 5, and we factored that. One more note that I always do get this question right here at this step when I wrote this as negative 10x plus 2x. You could rewrite it and put the positive 2x first and the negative 2x second, negative 10x second. It does not matter. So let's just make that note. It does not matter. Which magic number you write first. If you don't believe me, factor the problem again by rearranging it and you will arrive at the same answer. The only thing is your answers or your factors at the end will be in a different order. Okay? Let's look at our second problem here. 12x squared minus 25x plus 12. Same thing, let's set up our t-chart here. Now, our b value is negative 25. Okay, we're trying to add to that, and we're multiplying times a times c. Well, a is 12, and c is 12. 12 times 12, that's 144. Now, for a value like this, I wouldn't recommend that you sit there and list all of the factors. That might take you a while, especially when these values start to get bigger. So you have to be practicing your multiplication in order to know these things. So take a few minutes and try and come up with the factors, two numbers that will multiply to 144 but add to negative 25. If you identified the factors as negative 9 and negative 16, you were correct. So you're going to continue to go through and factor that problem as such. So 12x squared minus 9x minus 16x plus 12. We need to group our first two terms and our second two terms, and we're going to common factor. What is common amongst 12x squared and negative 9x? That would be 3x. If you divide or factor out 3x from 12x squared, you're left with 4x. If you factor out 3x from negative 9x, you're left with negative 3. What's common amongst our second pairing? Would be negative 4, leaving us, with 4x minus 3. Now, another question some people ask here is, how do I know when I'm factoring out a positive or a negative number? Well, if you notice, this value right here was negative 16, so I factored out negative 4. If you go back to the previous example, this number right here was positive 2x, so I factored out positive 1. Okay, so if that second value is negative, factor out a negative. If that second value is positive, factor out a positive. Okay, and now that we have the same thing in the brackets, we will rewrite our factors. 3x minus 4, so that's here and here, and then we have 4x minus 3, and we're done that problem. Okay, let's continue. Scrolling down. We have 7x squared plus 19x minus 6. We are looking for values that add to 19 and they multiply to 7 times negative 6, which is negative 42. Take a second and try and come up with those factors. If you identify those factors as -2 and 21, you are correct. Now go ahead and rewrite those into your problem. 7x squared plus 21x minus 2x minus 6. Okay, we're going to group our first two and our second two, and we're going to common factor. What is common amongst 7x squared and 21x? That is 7x. What does that leave us with? X plus 3. What's common amongst -2x minus 6? Well, that would be -2. If we factor that out, we're left with x and positive 3, because -6 divided by -2 leaves us with positive 3. And we rewrite our factors. What was left over? 7x minus 2. What's common is x plus 3. And we factor another one. Now if we look at the next problem, some might notice that the variable is no longer x and it's y. Okay, just if you need to make this note, it is the same process no matter the variable. So we're going to treat this the same way we have been. Sometimes we might even see multivariable problems, so we'll get into that eventually, but it is in fact the same process. So we're looking for values that add to -20 and multiply to our a, which is 4, c is 25, that would be 100. Now, feel free, pause the video so you can come up with those factors on your own. If you identify those factors as -10 and -10, you are correct. Okay. This one you're going to see a different trend as well. So same thing though. 4y squared. Rewrite your factors: -10y plus 25. Group your first two in your second two terms. We're going to common factor. What is common amongst 4y squared and -10y? 2y. If you factor out 2y from 4y squared, you're left with 2y. If you factor out 2y from -10y, you're left with -5. Okay. If same thing, second pairing, what's common amongst -10y and 25? That would be -5. You're factoring that out, you're left with 2y. 25 divided by -5 is -5. What you notice here when you're rewriting your factors in the final step is 2y minus 5, 2y minus 5. You have the exact same thing. Now, same thing as 4 times 4 can be said as 4 squared. Right here we have one binomial multiplied by another binomial, which is the exact same thing it is itself. So we're going to rewrite this properly as 2y minus 5 squared. Okay, this is proper math notation and would get you full marks. So review those first 4 problems. If you have to, go through them again. The next 4 are a little bit more challenging. They involve some different things. So please go back over that if you need to before moving on. But if not, keep scrolling and you will see those differences right away. So you notice that some of these problems have similar coefficients, different variables. Some have more than one variable, and some even have cubed and not squared. So we will get into some strategies that we can apply to problems like such. So same thing with this first problem, except we have p as our variable. So we're going to factor it as we have been. Well, our a value is 18, our c value is 1. A times c, it's 18. What multiplies to 18 but adds to -9. Okay, those values would be -6 and -3. Same process, we're going to rewrite those into our problem. Pair our first two and our second two terms in common factor. What's common amongst 18p squared and -6p? Well, that is 6p, leaving us with 3p minus 1. What's common amongst -3p and 1? Well, there is no greatest common factor other than -1, leaving us with 3p minus 1, and we factor this as we have been doing. Now, if you notice, problem E and F are similar in the sense that they all have the same coefficients. However, there's a second variable involved in our problem. It's going to follow the exact same process, okay, but we're just going to have to, when we do that first step of decomposition and splitting that middle term, we have to include both variables in those two pieces or those magic numbers that we're using, and this is what that would look like. So if you approach this problem, you would still set up your t-chart. What multiplies to 18, because you have a times c, which there's no coefficient there, so it's 1. And what adds to -9, we've identified those as -6 and -3 in our previous example. Now I'm going to follow these exact same steps. What did we do? Well, 18p squared. We rewrite our magic numbers using decomposition. This time, instead of just writing 6p, I'm going to write 6p cubed. Here I'm going to write -3p cubed. Okay, well, the only difference is I have two variables as compared to the one in my first problem, and then the plus the q squared. Everything else is the same here. Your common factoring, there's just a little bit more to look at. So what's common amongst 18p squared and -6p cubed? Well, first thing is common is 6. The next thing that is common is they both have p, so we factor out our 6p. What does that leave us with? Well, if we factor 6p out of 18p squared, we're left with 3p. 6p factored out of -6p cubed leaves us with just q. Okay, there's no coefficient common that is greater than 1 to our second two terms, so I'm just factoring out 1. But there's also, if you notice, a q associated with both terms, so we can factor out q. And sorry, I shouldn't probably write this 1 here, so it's just -q. Okay, then we have what's left? Well, 3p and -q. Okay, well, here we go. What do we have in our brackets? What is the same? That's 3p minus q, and then we have 6p minus q as our second one. And that is very similar to what we see here. The only difference you notice is one, they're in a different order, and that's alright. Still the same problem. And that our terms are not -1, -1, they're minus q because we had a multivariable problem. Okay, you have another multivariable problem here with g. Go ahead and try that multivariable problem now, following the exact same steps, and see if you can come up with the final answer. Okay, pause the video and take a shot at that one. So hopefully you are in the right ballpark for this one and you came close to this answer here. I know it looks like a lot in the final answer, as it is, but what you might notice is that if you're paying attention to this portion right here, and that was the problem that I gave you, just this by itself, could you factor that? Is there something common to both this term and this term? Absolutely. Well, you could factor out 3, and you could factor out y, which would leave you with what? Well, that would only leave you with x plus 1. Because if you factor out 3y from 3xy, you're just left with x. If you factor out 3y from itself, you're left with 1. So the real answer to your problem should be 3y, x plus 1, y plus 2. Now, I wouldn't recommend you do it that way. What you need to do first, and always ask yourself this question whenever you approach with factoring, is can you common factor the problem? Meaning, is there a common factor in the question right away, and that would be this problem right here. If you look at all three of those terms, so I'll rewrite it down here, 3xy squared plus 9xy plus 6y, there is something common to every one of these terms. First of all, you can factor out 3 from 3. You can factor out 3 from 9 and 3 from 6 without involving any fractions. Additionally, all of them have a y variable associated. You could factor that out. That would leave you with just x. That would leave you with, xy plus 9x, or not 9x, sorry, plus 3x plus 2. And this would be the problem that you would set up a t-chart for and factor as we have been doing. And it might be a little easier to do that. We will look at that right now in this example. Okay, so one thing you will notice here also is this cube term. We haven't seen that yet. We've been working with degree of 2 and exponents of 2. However, what you will notice is each of those terms involved in this problem h has a y variable. Therefore, we're going to common factor first. We're going to common factor a y out of each of our terms. That leaves us with y squared plus 7y plus 12. And now we're looking at a much simpler problem to factor, which is y squared plus 7y plus 12. So that's what we want to set up our t-chart for. What multiplies to 12, because we don't have an a value involved in what I've highlighted there, greater than 1, but adds to 7? Well, that would be 4 times 3, or 4 plus 3. So I'm going to do that again. And the only thing you have to keep in mind once you've common factored something out is just to carry it through your problem. So that y I've factored out at the start, I'm going to carry it with me. Y squared, I'm going to split that middle term into my two magic numbers, 4y plus 3y plus 12. Okay, I'm just going to look at this, and I'm going to common factor my first two terms. What's common is y. What I would recommend when you are doing this and you have double brackets is to use square brackets as well to help organize your problem. If you factor that out, you're left with y plus 4. Second terms, so these two right here, 3y and 12, what's common? That would be 3. That leaves us with y plus 4. Okay. Now, same thing. Carry that down. What do we have in our brackets that's the same? Y plus 4. What do we have left over? We have y plus 3. And there you factored that problem. Okay. That's why it is important to always common factor first. Now, those factoring problems are kind of tricky, so make sure you go over them and you're asking questions. But factoring is great. You use it in a lot of strands of math, but truthfully what we need it for is to help ourselves identify other properties of quadratics when we're doing this type of material. So let's continue on to a question that's going to apply some of our factoring knowledge to things we have learned in previous lessons and units. Now, here is the last problem. First things first, I made some changes, so make sure you're working on the right handout and that you do have, in fact, those two equations as you see them there that I've rewritten out for you. Your handout should have that. And this is kind of one of the reasons we do factoring, so we can identify these properties and help graph ourselves quadratics. Okay, so to factor the following quadratics and graph them on the grid provided using the x-intercepts and vertex. Okay, well, the first thing we need to do is to factor this, but I'm going to make a couple notes that are important to write down. In order to graph a quadratic without a table of values, you need the following. Okay, one would be the vertex, two would be the zeros, and sometimes it also helps to have the y-intercept, just to give you some points of reference, but those first two, vertex and zeros, are important. Okay, we don't always want to graph a quadratic with a table of values because it's time consuming. So we're going to show you a different method now. In order to do this, you must factor standard form quadratics. So you're going to take this standard form quadratic that you see here, and you're going to factor it. Once you've factored a standard form quadratic, you guessed it, you're now in factored form. Okay, so let's start with 4x squared minus 8x minus 5. So I'll rewrite it, 4x squared minus 8x minus 5. So if we were to factor this, we need our little t-chart to help us out. We're looking for values that add to negative 8 and they multiply to negative 20. Why is that? Because 4 times negative 5 is negative 20. What are those two values? Well, those two values are negative 10 times 2 or negative 10 plus 2. Go ahead and factor that problem like you have been doing so far. Hopefully you've factored that correctly and you have the same answer that I have. So your factors would be 2x plus 1 and 2x minus 5. Let me make note that these are your factors. Okay. In order to get your zeros, you need to set factors equal to 0 and solve for x. So our first factor was 2x plus 1. I make that equal to 0. That's what that would look like. And I want to solve or isolate for that x variable. So I'm going to bring that over. 2x equals negative 1. Divide both sides by 2. My first 0 is equal to negative 1/2. Same thing for my second factor. I have 2x minus 5 equals 0. Okay, isolate or solve for x. 2x equals 5, and therefore my second 0 would be equal to 5 over 2. Do not make those into decimals. Let's just keep them as fractions. It makes our problem that much neater. Now, we have one piece of the information we need, which is our zeros. We need to use that to find our vertex. And some of you may be thinking this already, but we can solve our axis of symmetry because the formula for an axis of symmetry is x1 plus x2 divided by 2. Okay, well we have 2 points like such. So negative 1/2 plus 5 over 2 divided by 2. Well, negative 1/2 plus 5 over 2 is equal to 4 over 2, or 2. And 2 divided by 2, that equals 1. So our axis of symmetry, or the x value of our vertex, is 1. We need to find our optimal value now, or the second half of our vertex. In order to do that, we need to plug our axis of symmetry that we just got back into our original equation. Okay, that's a value of x. If we plug it in for x, we can solve what y would equal. So we have 4 times 1 squared minus 8 times 1 minus 5. Well, 1 squared is 1, times 4 is 4, 8 times 1, and minus 5. 4 minus 8 minus 5 gives us negative 9. Okay, that is our vertex. Our vertex, therefore, is 1, negative 9. We have all the information needed to actually graph this problem. Now, the other piece of information that I said might be helpful is your y-intercept. Now, you can find this in a standard form quadratic. It is always your c value. So our c value here is negative 5. Okay, our y-intercept is negative 5. We don't need to do any solving, substituting. Our y-intercept is 0, negative 5. Now, we use all this information to graph. How do we do that? We just plot our points. Okay, so I'm going to draw a grid up top, and you can follow that example here. So I've drawn a 4-quadrant grid here on our graph. Okay, and let's recall our pieces of information that are important. Our 1 is our vertex and which is 1 and negative 9. So if I just use a scale of 1 on both my y and x axis, here's 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we go. That's 1, negative 9. Okay, and that would be our vertex. Other point of interest was our y-intercept, which is 0, negative 5, which is right here. Okay, and then our other 2 points were our zeros, and they were down here, so negative 1/2 and 5/2. Now for this sake, you can think about those as decimals. Negative 1/2 is negative 0.5, which would be right here. And 5/2 is 2.5, which would be right here. What you want to do is, now that you have enough points and you can kind of see the outline of a quadratic, is draw some sort of smooth curve. So do your best to do this. It shouldn't be done with a ruler because it's a curve, not a straight line. Okay, I'm going to do the best to do this on my tablet. Okay, and there you have this quadratic, and you draw those arrows on the end, signaling that it is continuing, that those are the pieces of information that you know about. Okay. What I would like you to do is now try this problem on your own. So 3x squared plus 11x plus 6. This one has a little bit of fractions involved. Okay, but if you're successful, so for B, you have 3x squared plus 11x plus 6. Okay, what are you looking at? Well, in the end, you should get your x-intercepts or zeros to be negative 2/3 as 1. Your second one would be negative 3. Your vertex, which is a little trickier to solve because there's some big fractions involved, is negative 11/6. Negative 49/12. And your y-intercept, which you can just see clearly there as your c value, is 0, 6. So try and solve that by factoring and following the same steps as problem A, and see if you can come up with those pieces of information and then also graph it. So I hope that helps. There's a lot there to digest. You might have to go over that a couple of times. Feel free, and then seek out extra help if need be. All right, good luck, and try and complete those suggested exercises out of our textbook as well.